enter the last last round of this fight. Okay, so I want to ask opponent to you have 1 minute to pick up problem to challenge the reporter. Which one? Number 3, okay. Problem number 3, apple. So we have 1 minute to decide. Accept or reject. Okay. The problem has been accepted. So also each team please write down the name of the presenter on the back of the house.
Please start.
Hi, I'm the reporter today for problem 3, Lato. Overview. Concept will contain how Lato start, how to convert a vertical force into a horizontal force, coefficient of restitution, small angle simple pendulum period formula. Problem statement. Attach a ball to each end of a string and connect the center of the string to a pivot. When the pivot oscillates along the vertical direction, the ball starts to collide and oscillate with increasing amplitude. Investigate the phenomenon. Experience setup. We place a scale with 5 centimeters in the wall and use stickers to make sure the camera is in the same place. And make the camera in the wall 2 meters and make sure it is parallel. Experiment method. We record the video and use tracker and Excel to analyze it. Experiment method. One ball is 7.7 gram, another is 7.8 gram, and radius is 1.5 centimeter. Concept. The initial speed is necessary to start Lato's movement. Without a gap between two balls, the oscillation never begins, as you can see. And with a gap, initial speed is necessary to start Lato's movement. And initial speed. This is how vertical force turn to horizontal. This is tension of the rope, and this is gravity. So it will be a horizontal component. This is from the perspective of force. And this is from the perspective of energy. This is gravity. And when it falls, the potential energy will become kinetic energy. So it will be a speed like this. MGH become half mv squared, and when it collides, will become half mv prime squared, become MGH prime. Okay. This is U1 and U2 is initial speed, and V1 and V2 is final speed. In elastic vertical mass, if M1 equals M2, V1 equal U2 and V2 equal U1. And if U1 equal U2, then V1 equal U1. But in that case, it is inelastic. So U1 equal U2, V1 equal EU1. This E is coefficient of restitution. This coefficient, if E equals 1, and when it impact, it will return to the same height. Concept. This is initial height, and this is final height. V1 equal alpha V, and this is initial speed. This is final speed. This alpha is coefficient of restitution. MGH become half mv squared, and multiply alpha squared equal become half mv squared, and v1 squared become MGH prime. H prime equal alpha squared h. This is one impact, and H double prime equal alpha squared h prime equal alpha squared h. This square is number of impact, so it will be like this. This is time, and this is period. You can get this. And when it alignment, you can get this. Oh, this is fitting line. You can get this. Concept. This is simulation. When E equals 0.86, so it is inelastic. It might be a forced oscillation. Just wait. It's almost the same height in yen. another simulation. When E equals 1, this is elastic, but it's still forced oscillation. You can see, like before, we think it might be like when my string is tightened, it will be some energy, a part of energy turned to the peak. Data analysis. I use hand to do the experiment, but as you can see, my standard deviation is 0.004, so it's smaller than 1 centimeters. And every high point subtract lowest point is almost the same. So I can get my handmade, the dual my handmade is 0.005. And when I go hit in a high place and I don't move my hand, it will decay. So I can get this line. So can get a fitting line, and it is exponential decay. This is still our length of the string is 0.2 meters, and gravity is 9.8, and period is 0.89, and this is practical. And 0.83 subtract 0.4 multiply 2. This two number is 2 height points because this is 1 period, but when lateral it going here and back to here. So its period is subtract the 2 height points multiply 2. And this 2 is in this here and here. And I can get the coefficient of restitution, orange and yellow ball, and it is 0.91 and 0.89. Conclusion. An initial speed is necessary to start lateral movement. With a gap between two balls, the oscillation can start. Calculate the period using a small angle pendulum formula and derive the coefficient of restitution through the kinetic to potential energy equation. Estimate the energy input from the hand during stable oscillation and plot the fitting line. Thank you, everyone.
Okay, thank you. So, short question from the performer, please.
How do you control the force in reality?
My hand can control.
You can control. How do you make sure that every time you pull up and that's the same force?
You can see. I think the standard deviation is so low, so it might be ignored.
Okay, and then you pointed that you ignore, you assume that the angle is small, but obviously in your demonstration it's not small angle. The angle is very big.
Maybe yes, but it's very similar with the same period. I think.
Did you point out the period?
What period? What do you mean? So
Okay, next question. You use tracker, right?
Yes.
You track you track the mass of the point, right?
Yes.
But actually, in your demonstration, you can see that the ball will be spinning. So it will be very difficult for you to track the same point because it will spin, and the camera can't record it. You know that?
So I use my eyes and my hand.
So obviously that's not accuracy. And where's your arrow bar?
Arrow bar. No, sorry.
Okay, thank you.
Thank you. So now you have 3 minutes to prepare your presentation. Opponent, please.
Hello everyone, I'm the opponent from Team Haha, and the problem is number 3, Lotto Lotto. And this is the problem statement. And there's no key points for the report. A briefly summary of the reporter. They use the inelastic and elastic collision, and their experiment method is using coding simulation, and the data analysis is using tracker to track their videos and get the data. And their conclusion is that initial speed is required. Small angles can formula used to calculate. And this is of course pros and cons for the reporter. For the pros, they have clear experiment setup and clear demonstration. However, they don't have numbers of pages, and there are lack of theoretical fitting, and also they didn't consider the force in their data. And my discussion with the reporter is that for the theory part, what can I go to the next stage?
Okay, you can go to the next stage. So, please.
Can you go to the theory page?
What
The,
theory?
the M, the velocity you calculate.
So this.
Theory. Sorry. The next page. This way. You're not using the same mass of wall, right?
Ah, yes.
Then why do you think that you can use this equation to answer data?
No, I just say that plasma phase is inelastic.
How do you know that it's inelastic?
Because I analyze it and know the coefficient of restitution is 0.91 and 0.89.
Okay, but for your further saying that, you're saying that it's not accuracy, so I believe that you should do it more accurate so that you can confirm that your result is correct. Okay, the next question. Is there a way to quantify the energy loss, do you think? Is there a way to quantify the energy loss?
I think might be, but our team don't.
Sorry, can you speak it louder?
Maybe it had, but we didn't do it.
Okay. Then what way do you think we can calculate?
Maybe we can simulate compare simulate and practically compare simulate and the
Okay, I got your
okay.
And for your simulation of coding, why do you suppose that E is equals to 0.86?
So 0.86 is just to simulate the.
Also, there's no accurate meaning for the 0.86. It's just because it's 0 to 1, right?
Yes, it's just to simulate.
Okay. And how do you consider the force in your simulation?
The first of. Can you speak again?
How do you consider the force in your simulation? The force you put it up.
This is simulation. This simulation is just to talk when it is elastic or it is inelastic. It both are force oscillation.
So in all cases, you didn't consider the force, right? Okay. Then how about you think that consider using damping equation to quantify the energy loss? Because do you think in the future sometimes we can do it, or how you can do it?
Can you speak? Sorry.
Okay. Do you know damping equation?
What is damping equation?
Can I use the back?
Yes, please.
it might be some energy. A part of energy became to the heat because of the tension below. It might be short.
Okay. And do you calculate the tension?
Oh, no. Yes, no. No.
Okay. Can you jump to the data analysis? Thank you. Next. Fast forward. That's okay. And this is one of the damping equation, and you calculate this as your E, right? And do you know that this is come from the damping equation? And why do you use this?
You say.
Oh, just because that's
The thing I say, so I align this. You say this.
Can you explain the differences between E equals to 1 and E don't equals
When E equals 1, it impact and will return to the same height. But when it is 0 to 1, if I don't make any energy to that, it will lower and lower.
1? Okay. And can you jump to the simulation of your E equals to 1? Remember you said that 1. Remember you said that if E equals to 1, it will remain the same height, right?
Sorry, I didn't.
You forgot to consider the force, right?
Yes. E equals 1 is it might be the distinct result, but it's force oscillation because of the tension of the rope.
And about your period, how it decay does the period change in the decay? Go to the E equals to 86. Yeah, do you know that it will just decay. And when it decay, does the period change?
In this version, I will use my it will be a energy that adding, so it will not. Okay.
Okay. This is the different equation, and can you simplify calculate? Do you think that you can calculate this?
So this program is what?
Damping. Damping is.
Okay, please speak louder.
Oh, sorry. Okay. Damping equation is what you just said, that if it's elastic, then it will just slowly or it will just decay and decay and decay. And eventually, some of the damping situation, then it will just stop. So the damping equation is talking about this.
You say what time it will start or
Okay.
volume to calculate this. This is just the number, and this is Q.
Okay, and do you know that the diagram should be like this and decrease to 0? Yes, exponential. Okay, but we're not decreasing to 0. You should track until it becomes 0. It will be a better experience. And did you consider the ball will move forward and move back? It's not totally 2D motion. Do you know that?
You say now the surface.
It's not 2D. It's 3D.
Oh. I don't know how to.
Yes, you consider the forward and the back of the whole motion.
No, it's just 2D.
And what do you think? How can you consider?
You say how can I consider a 3D model?
Yes. Since that's real in reality. Thank you.
Okay, thank you. And opponent, please summarize your discussion.
We talked about the reporter control the force or not, and the reporter said that he didn't consider, but however he will do it in the future experience. And the reporter, when I asked the reporter about the damping equation, he don't know what's damping equation. And however, in our discussion, I think that he knows what's damping equation through our discussion. So I think this is a good discussion. And then we also talk about that the mass, the different mass of the ball, and also the simulation of the coding.
Okay, thank you. So question from the review.
Okay, I gonna ask both opponent and the reporter. Did you consider that the string will do work to the laptop? Do you consider it will do work to the laptop?
I think it's the hand key.
Hand didn't contact with the laptop. How do hand do work to laptop?
Might through the string.
The string do.
Might through the string.
Yes, but how to analyze it? The opponent.
I don't think it will, because the string is virtual to the ball.
Yeah, actually it seems virtual as you consider this is the center of the rotation, but this lateral its velocity is not actually virtual to the string. It would have a background velocity while our hand is moving up. So the string may not be purely virtual to this velocity. And this is why we can make it go faster and faster while we speed it up. And can I display this here?
We can,
If you have done something, you can X perpetuate from the reporter to the
How about, did you have any experience about how to success a lateral collecting graffiti? Any experience? I mean the critical condition for making it speeding up and down.
actually, in the problem statement, it didn't say that it has to be up and down, right? It didn't mention.
Yeah, maybe.
And to make it faster is because the resonance
is resonant means?
The same frequency of your hand and the natural frequency of lateral. When it's same, then it will be then it will have
It will be half natural frequency.
Yeah, but I mean, if the lateral speed up in initial velocity, how would it be higher and higher? You need extra energy. That means the string will still work. Right? Well, I consider the
Time's up. So you have 2 minutes to prepare your presentation. Okay, you will take the floor.
Okay, so we're review Aska banana. And the problem statement is here is below. And the overview of the reporter. The reporter focuses on the initial speed and gap to make all the oscillation start. And the energy transfer between potential energy and kinetic energy, and also focusing on the E of COR. And the experiment, reporter used both computer model and their own model to compare. And for the conclusion, the initial speed and gap they have detect to make the oscillation start. And for the energy aspect part, they detect the COR and got the energy transfer between, and they discover how energy transfer between the kinetic energy and the potential energy. And they use small n go to model this phenomenon. And for the advantage to the reporter, they are hardworking on both theory and experiment and are accountable. And for the suggestion, first, voltage and numbers, so it is hard to mention what which page is talking about. And second, some of the data lacks of the unit. And last, I would like to consider some of the experiment that lacks a little bit accuracy. And this is now is the remarks for the opponent. The advantage is they focus on the accuracy, but this is also the suggestion that lato cannot be displayed by the robot. So accuracy is sometimes it is not avoidable. You need to play it with camera. And also, before we start observing the phenomenon, try not to discuss about the function first, because we may have to observe the phenomenon first. So don't just deliver some function or equation into this program in the first time. And for the discussion, I have discussed, first is that why is the equation used while the mass of people are not the same? The opponents say this model is not accurate because the two poles is not same in the mass. And another discussion is about the energy loss. The opponent says that using COR to calculate. The opponent says that this.
Okay, I'm sorry, time's up. So concluding remark from the report.
Okay. The mass of different balls are the same, and after analyze in elastic of them, the number of them are almost the same. The mass of them are also the same. Let's do the work to lateral, and reporter say the handler did work to the string. And experiments we use hand to control lateral. And we look at lateral tuble's position, coefficient of restitution, and how much joule is by the handler. So it may not so accurate, and we think we need to consider both spin, and that might not so small angle, and need to consider 3D situation.
So questions on the table?
In a night market, sometimes we see a toy similar to the lato, but with the string made of plastic. Do you know what I mean? I want to know what's the difference if we use the plastic string for lato. How's your opinion?
The string tension will be different. The night markers using plastic, then it means that it will not, compared to the one that of the reviewer, the reviewers will softy and not be strict, and it will certainly affect the accuracy of the lateral.
Number two?
Using lato, maybe you can ignore the weight of the string. But if using that kind of plastic toy, it is made of both the supporting part and the ball.
Yes.
So this part, the center of its mass may not be in the ball. Then there's more things to consider. First is the rotating. Maybe you could consider it as a spinning. And also, well, it's continuous. each other, bumping onto each other. I don't know how to take equation of it, but I know that there's a difference. That's all.
Okay. In that toy, it might be 2D simulation, I think. And and the string will not be take. The string maybe not the string, the tighten string, the string won't tighten, so the energy maybe won't turn to the heat.
Okay, thank you.
Actually, there are many factors influence the oscillation, and I just want to know, up to your knowledge, what's the factor that influence the oscillation?
The length of the string will definitely affect the period of the lateral. And also, the tension, I just mentioned that it will also affect that. And the mass of the ball, the force that I pull up, and the initial velocity that I give it to it.
Maybe the waving range of our hand, because this is considered the center of the system. Maybe we can consider the hand is the center of the system. Then waving means doing extra energy to the system. About the construction of lateral, like the bow, the mass, and the string, is also should be considered. And materials of the bow.
Yes, my hand material and the material and the mass. Another might be the string. The string material might different tension, cause different tension.
Okay, I want to continue almost a similar question. So now you have two things. One is the force, how large the force you move. The other is how fast you move up down, the frequency. Okay, so if you consider these two parameters, you want the ball move higher. What would you do? Okay, that's my question. So how about the highest? You want to move the highest?
You say how I
That's two parameters.
Make
One is the force. One
make
is
it
the
higher and higher. How I make it higher and
How do
higher?
you do it?
I use my hand and its natural frequencies have its natural frequency, so it can be higher and higher.
So how about opponent?
I think that when the frequency is matched, then it will make it.
Just come to one is the force, how big the force you move. The other is how fast you the period, how fast oscillate you hit.
When the features match, when the frequencies is matched, then it will be bigger and bigger. The height will be bigger and bigger. Higher and higher, sorry.
Okay.
I think the frequency may not need to be matched, but the frequency may need to be matched in later rotating. But in the initial case, the frequency may not need to be very matched, but we need to add an extra force on a critical angle to make sure that after moving this ball upon this critical angle, it would have extra energy to move higher and higher.
Okay, cool. Thank you. Can I go to the boring section? Okay, let's go to the scoring section. We start from the order first. Which rates was called? Okay, 4, 6, 4, 4, 4. Then opponent. 6, 8, 7, 7, 6. Then viewer. Yes, please. 5, 7, 5, 5, 4. Okay. Looks quite consistent. Was there any jury want to say something? Okay. Then thank you everyone has closed this first 5.